Okay, hello and welcome to GPS Manipur. Now I'm going to discuss about reflection from spherical mirror. Okay, it is 11.2, page number 205. Okay, I'm going to discuss about this. Now we have discussed so far about plane mirror, right? There is a mirror, okay, and okay, you can see here there is a mirror is like this, and in this mirror one side is back side of the mirror, another is the reflection side. And what was happening was, I've drawn a line like this is incident ray, this is reflected ray, this angle and this angle are equal. We have discussed. Okay, now I want to discuss about spherical mirror. Okay, what do you mean by spherical mirror? Let's take a sphere. Okay, this is an example of a sphere, okay, like football type. Okay, let's take a football type thing. Now if in this football type of thing, if in this football type of thing let's say in this football type of thing, let's say it has two parts, like or if outside one is mirror. Okay, think about football, and out the cover of the football is mirror. Okay, so the shape of the mirror is like this. Can you see? It's complete football. Okay, or we can say the same football, it can be like in outside is mirror, or it can also be there that inner surface is mirror. Okay, from inside it is mirror, outside it is polished. Are you getting the point? There are two things, like take a football, take a sphere, take a sphere, and from that sphere, let's say there are two conditions it can happen. One is outside part. Okay, outside part, outside is mirror, or it can be that inside part is mirror. Are you getting my point? Inside is mirror, inside is mirror. Okay, now what I'll do is I'll cut a piece. Okay, I'll take a piece like this, I'll cut this particular piece. Let's say, let me cut like this. Okay, I'm cutting a particular piece from here, and I'll take it out. Okay, this part I'm going to take it out. Okay, now if I take it out, and if let's say from this part, the part I have taken out, let's say this is the part I've taken out, like this. Okay, this is the part I have taken out. Now there are two things. One, if inside is mirror or if outside is mirror. Okay, let's say if inside part is, outside part is mirror. Okay, inside is not a mirror, outside part, the outside of the football. Okay, from outside it is mirror, from inside it is not mirror. Okay, from outside it is mirror, then this kind of mirror is called convex mirror. Are you getting my point? Outside part is mirror. From the same sphere, if outside part is mirror, outside part is reflecting side, and inside part, okay, it's not the reflecting side, then this is called convex mirror. Now from this, let's say the sphere is such that the inside part is reflecting. Okay, not the outside part. Let's say that if I take a space, if I cut out a piece, and let's say outside part is not reflecting, but inside part is reflecting. Are you getting my point? That is called concave mirror. I hope you understood this one. Okay, I hope you understood this one. So this is concave mirror and convex mirror. So what are the things that can be asked from this particular point? The question that can be asked from this particular point is, define concave mirror and convex mirror. So how to define concave mirror? Let us define. Concave mirror, what is concave mirror? It is a type of mirror. Okay, concave mirror, what is a concave mirror? Concave mirror is a part of, concave mirror is a part of a hollow sphere, part of hollow sphere. Okay, where the inner part, where the inner part or inner side of the sphere is reflecting, is reflecting surface. Why am I not able to? Okay, inner part is reflecting surface. Are you getting my point? The inner part is reflecting, outside is not reflecting. Okay, football, okay, from inside, okay, it is reflecting, outside it is not reflecting. This is concave mirror. Convex mirror is same thing, but it's opposite. Okay, convex mirror, convex mirror is a part of a hollow sphere where the outer part or outer side, I've written on side, right? Outer side of the sphere outer side of the sphere is reflecting surface. Are you getting my point? I hope it is clear to you. So this is one of the question it can be asked. What is concave mirror and what is convex mirror? Now there is another thing, activity 11.2. It's given in a textbook. They are talking about like example of concave mirror and convex mirror. In that, they ask you to take a spoon. You know spoon, right? Can you see the spoon here? So this spoon has two parts. One is front part, another is back part. If you look in the front part, you will see that it is concave type. It is concave type. And if you look at the back part of the mirror, back part of the spoon, it is convex type. So what activity 11.2, what they are asking you is, they are asking you to do the experiment with this spoon. Take the front part of the spoon, okay, look into that spoon, and take the back part of the spoon and look into that spoon and conclude what you can conclude from there. Okay, then you will come across that if you take the front part of the concave mirror, if you take the front part, that is concave side, the front part. Okay, so the spoon, let's say the front part, which is concave mirror part, is front part of the spoon, front part of the spoon. Okay, and convex mirror is back side or back side of the mirror, back side of the spoon. This is a very good example of concave and convex mirror. Now if you look carefully, you will find that in the front part of the spoon, if you look from little bit far, then you will find out that it is, the image form is inverted. Okay, inverted means if you are standing like this, then image inside the spoon, okay, image inside the mirror, we can say inside a concave mirror, it will be like this. Okay, and if you go closer and closer, if you go very close to that spoon, okay, you'll find out that the image form is like this. If you go very close, then it will be like this. Okay, it's not inverted, it is erect. Okay, so first it is inverted, and if you go very close, it will be erect like this. Are you getting the point? So the image form is like this. And another thing is, if you are standing very far away in front of the concave mirror, then you'll find out that the image is small, and as you go closer and closer and closer, it will become bigger and bigger and bigger and bigger, and it will be magnified. If spoon is there, so size of the image increases, size of the image increases as we go closer and closer. Okay, you can do this experiment. You can take the spoon at a home and try looking at this. This is activity to be done by you. Now what will happen in the convex mirror? It's the back side of the spoon. Okay, if you look into the back side of the spoon, you'll find out that the image is smaller. Image is smaller, always smaller. Okay, image is always smaller than the object. Okay, and another thing is, it will not be like, if you look like this, it will be small, but it will be coming out like this. Okay, it will be erect. Okay, it will be always erect. Okay, are you getting my point? It will be erect and virtual. In case of this part, it is virtually erect, but if you go very close, virtually erect, no, it is real and inverted, it will be opposite, right? It will be real and inverted, but if you go very close, but if we go very close, it will become virtual and erect, virtual and erect. Okay, all these things you can look into the mirror and conclude. Okay, so what you can conclude from this activity, I hope you can write all these things. Okay, I hope you can look into the spoon and conclude from there. Okay, let's go to the next topic, that is some of the terms and definition before studying image formation of a spherical mirror. So whatever this concave mirror, convex mirror we have discussed using spoon, we can also conclude. Okay, soon we are going to learn about it, don't worry. Now let us discuss. First is center of curvature. Now, in the definition, while defining, I have told you that the concave mirror or convex mirror is taken from a sphere, right? There is to be football, from that football type. It's not exactly football. Football also there can be outer part is reflecting or inner part is reflecting. And if inner part is reflecting, okay, then it is called concave. If outer part is reflecting, then it is called convex. We have discussed. Now, center of curvature. What do you mean by center of curvature? Now that sphere, the football type, it will have some center, right? Are you getting my point? The sphere, this the sphere, okay, the sphere which you are taking, it will have some center. That center is called center of curvature. What do you mean by center of curvature? Is the center of the sphere. So it is the center of the sphere. Which sphere? Which sphere? Sphere of which spherical mirror is a part of, is a part. From where you are taking out the mirror, that center, okay, that is called center of curvature. Radius of curvature. Now if you have taken this center, okay, then it will have some radius, right? This is the radius, right? So this is called radius of curvature. So what do you mean by radius of the curvature? The radius of the sphere, which sphere? Of which the mirror is a part, of which the mirror is a part. I hope you can understand this. This sphere, this is the center C and the radius R, right? This is the radius. This is called radius of curvature. Pole. What do you mean by pole? The central part of the mirror. Okay, sir, what this can you see this concave mirror here? Can you see this concave mirror here? This one, this part, right? So in that mirror there is center, right? This point, center, this is called pole. Okay, they can write A or they can write P depending upon. Okay, let me write on A here because the book, I think it is they have written A. Okay, so what is pole? Pole is the central point, of the mirror, or the point on the mirror directly facing the object, okay. What is the central point of the mirror? The mirror which is facing the object. Okay, sir, where is the object? Okay, we'll discuss, but now the central part of the mirror, this is called pole. I hope you can understand this much. Sir, what about convex mirror? Where will be the center of curvature? Same thing, right? You can take a sphere, this is taken from the sphere, right? There will be some sphere you cut and outer part is reflecting, this is convex mirror. And even that mirror also will have some center, right? That is center of curvature. Even that mirror will have center point, right? That is pole. And it will be, there will be radius of curvature, right? This is radius of curvature. Are you getting my point? So even in that also we can find out whatever I'm discussing here. Now another thing we need to discuss is principal axis. What is principal axis? Principal axis is nothing but a line that is drawn from pole, which is pole, this is pole, right, and center of curvature. Okay, so what is principal axis? Principal axis is a straight line. It is a straight line. It is a straight line that passes through the center of curvature, through the center of curvature, center of curvature and pole of the mirror. Are you getting my point? You take a straight line and make it pass through pole and a center of curvature. Both these two point must be touched by this line, and this line is called principal axis. I hope it is clear to you. Are you getting my point? Now another thing we need to discuss is principal focus. What is principal focus? Now this is little bit complicated. Okay, for principal focus and focal length I'll discuss after this image formation rule. Okay, so but okay, fine, let me just define, and if you didn't understand, don't worry, I'll make it clear soon. Okay, what is principal focus is? Principal focus is nothing but, let's take concave mirror. Okay, let me take a concave mirror. Okay, outer part is polished and inner part is reflecting. Okay, now what is principal focus? The definition of principal focus is, if you take a straight line which is parallel to principal axis, this is my principal axis, right, this one, this is my principal axis, and I'm taking a straight line that is parallel to the principal axis, then after reflection it will pass through focus. That will be my focus. Understand again, if I take a straight line, okay, we'll discuss this in rules also, don't worry, we'll discuss again, it will become clear to you. If I take a straight line which is passing parallel, this is the line, right, parallel to this, if I make a line, straight line, then after reflection from here it will pass through focus. So what will happen if I take little bit upside like this? Yeah, the rule is same, it will pass through focus. If I take like this, it will pass through focus. The only condition for this to be passing through focus is it must be parallel to principal axis. Okay, so looking at this, we can define principal focus. Okay, what is principal focus? Principal focus is, it is a point, it is a point on the principal axis, it is a point on the principal axis. Okay, what is the condition of this point? So it is a point on the principal axis in which, through which the line or through which the reflected light, through which the reflected ray passes, after a parallel incident ray, after a parallel incident ray, after a parallel incident ray is, after a parallel incident ray is made to strike the or hit the, how shall I write, after incident ray is made to, let me just around hit the, heat will not be good word, I didn't find the exact word. Okay, after a parallel incident ray is made to hit the mirror. Okay, now what we did is, whatever what it is a point on the principal axis, so it is a point on the principal axis where a line, where through which, okay, it is a point on the principal through which the reflected ray, the reflected, okay, this ray is reflected, right? After a parallel line, the parallel line will go and get reflected and it will pass through focus. Okay, I hope it is clear. Don't worry if it is not clear also, we'll make it clear. Okay, we'll make it clear soon. So there will be a point, okay, there will be a point, let's say, where, let's say, where the reflected ray, okay, let me make it here, it will be clear here. Okay, I can actually do there also. If I take a ray parallel like this, then it will pass through focus. Got the point? Now focal length, what is focal length? Focal length is the length of this one, this is focal length. Okay, focal length, what is focal length? Focal is the distance between focus and pole. This is pole, right? A is pole, f let us write down as focus. So I can write down focal length as, what shall I write down? Focal length is, it is make it a little bit darker, it is the distance, it is the distance between focal length, it is the distance between focal length, no, sorry, it is the distance between focus and pole of the mirror, focus and pole of the mirror. I hope this is clear to you. I hope I'm able to make you understand the concept.